Okay. Hi everybody. It looks like I can see my slides are up on the screen. So today I'm going to be talking about the state of Deno in 2022 as the year kind of winds down. My name's Colin Ihrig. I am an engineer at Deno. I've been there for almost 6 months now. But yeah, let's go ahead and dive right in. So even though this talk is about Deno, I wanted to start with a little bit of background that includes Node.js. So Node.js has been around since around 2009, and it actually predates a lot of what we consider to be modern JavaScript. So for example, if you've used Node's require, which is something called CommonJS, versus ES modules that got introduced into the spec a lot more recently. Node still has a lot of APIs that support callbacks, whereas the JavaScript ecosystem has kind of migrated to doing more things with promises and async await. But on the flip side of that coin, it's not all bad. Node does have a really large ecosystem with a lot of legacy code. Um, and that legacy code can actually slow progress sometimes and make standards compliance a little more challenging because we don't want to go ahead and break all of these people who have been using Node for so many years. um, so Deno, I would say, takes a much more batteries included approach to being a JavaScript runtime than Node.js does. And that is something that I will talk about a little bit later in my slides. So a little bit of a timeline here. I think a lot of people are probably familiar with the talk that introduced Deno at JSConf EU in 2018. It was a talk given by the creator of Node.js about some of the things that he regretted about the platform. So that talk happened in June of 2018. By August of 2018, Deno 0.1.0 had been released. And this was significant because it included a rewrite in Rust. So Deno was actually originally written in Golang, but it was moved to Rust so that you could avoid having multiple garbage collectors in the same process. So obviously JavaScript has its garbage collector. Golang is also a Java or a garbage collected language. So having the two of those kind of living in the same process could lead to some unpredictability as far as performance and things like that. So Deno was rewritten in Rust, and then fast forward to May of 2020, and Deno 1.0 had been released. And then a few months later, in March of 2021, the Deno company, which is the corporate entity behind the project, was announced. And you can see the little picture here on my slides is an actual picture of the Deno offices with all of the people working. In June of 2021, Deno Deploy was announced. Deno Deploy is a JavaScript runtime for running your applications at the edge. And I'll also get into that a little bit more as the talk goes on. But currently, Deploy is supported in 34 different edge locations around the world and is continuously growing. It has some really cool features like allowing you to deploy your code in just a few seconds. You can actually save your code and then do a small countdown and actually see it get deployed, which is really cool. And we are hoping by early next year to have Deno Deploy reach general availability. It's still technically considered in a beta state. So I wanted to talk a little bit about Deno's growth. So here I have graphs of the GitHub stars for both Node.js and Deno. So I guess first thing to point out is for Node.js, the tool that I used to build this graph only went back to around 2015. The actual timeline of the project would go back to 2009. So while the star counts here are accurate, the amount of gap here shown by the arrow is actually much larger. So I would say, Deno has increased in stars pretty quickly. Um, right now, I think Node.js is at around 90K and Deno is about 85K. So Deno is catching up to Node. I do want to say that this is talking about GitHub stars, which, are just kind of a proxy metric for how much something is actually used. I mean, it doesn't take anything to stop out a GitHub repository, star it, and never look at that again. Um, but we do actually have internal metrics where we're tracking growth, showing that the project is still actually growing. So this is, while it's a proxy metric, it does kind of reflect reality too. The next thing I wanted to do was talk a little bit about the core technologies behind both runtimes. So both are JavaScript runtimes built on the V8 engine. V8 is the engine from Google that is used to power Google Chrome and some other projects, but we're going to focus on Node and Deno here. And that is kind of where the similarities end. Other than executing JavaScript, the actual platforms are written in, for Node.js, it's C++. For Deno, it is Rust. And I'll talk a little bit about how Rust is kind of used in a couple slides here. Um, both runtimes have an event loop and can do asynchronous I/O and different things like that. For Node.js, it's a library called libuv that is used, whereas Deno uses a Rust library called Tokyo. For TLS and crypto things, Deno uses something called Rust TLS, whereas Node uses the OpenSSL project. For HTTP stuff, Node uses a project called LLHTTP, whereas Deno uses a combination of libraries called Hyper and Request. And I have a little asterisk here because Deno is actually shipping another experimental HTTP server called Flash at the moment. Flash is an internal project that is kind of geared at becoming the fastest HTTP JavaScript server ever written. So it's still experimental now, but it's showing a lot of promise. And then finally, the libraries that we use for DNS in Deno is something called Trust DNS, and in Node, it's a C library called Cieres. So next, I wanted to talk a little bit about the core architecture of Deno. So as I mentioned, Deno is built from a bunch of Rust crates, but V8, the engine itself, is actually written in C++. So we have a library called Rusty V8, which provides Rust bindings to the V8 library. So everything above Rusty V8 is able to be written in Rust, and Rusty V8 kind of isolates the C++, bad bits from everyone. Another kind of nice bonus to using Rusty V8 is that it can prevent you from having to build V8 from source. So you can just install a pre-built version. If anyone has ever actually tried to build V8 before, it can take a significant amount of time and really make your laptop get pretty hot. So yeah, on top of Rusty V8, we have this Rust crate called Deno Core, which includes Rusty V8 as well as something called Deno Ops. Ops are actually Rust functions that are callable from JavaScript. So in something like Node.js, this would be your binding layer that calls C++ code. But the ops in Deno are actually much more restricted. So it's kind of a choke point for going between JavaScript and TypeScript in the native layer. It's nice because you can control how people are accessing the native layer. It's much more secure, and it gives you a way to kind of collect metrics about these different native operations that people are calling into. The Deno core crate does actually provide a usable JavaScript runtime, but it's really minimal, and so we want to build some more things on top of that. And so that leads us to the Deno runtime crate. So it's a much more complete JavaScript runtime. It's something that you would actually feel comfortable using. It includes all of the core crates that I just mentioned in the previous slide, but it also brings Tokyo into the mix, as well as a number of other crates that do, implement various APIs. So if you look here, Deno console implements things like console log and all of the console APIs. Deno crypto is the crate that handles doing things related to crypto. Deno fetch implements the fetch API and so on. And that is kind of how the runtime itself gets built up from more and more crates. Then the final thing is the Deno CLI. So this is what you would actually download and run. It's distributed it as a single executable file, and it will always be distributed as a single executable file. It includes the Deno runtime crate that I just mentioned, but it also includes a really powerful integrated toolchain for doing things like linting, formatting, a bunch of other things that I'll talk about in a couple slides. But it's basically everything that you would, supposedly ever need to write a Deno program and run your Deno programs. And so Deno currently runs on Linux, Mac OS, and Windows. That we are thinking about expanding out into some other platforms, but GitHub Actions supports those three, so those are kind of the big three that we're focused on now. And I've also added a link here at the bottom in case anyone's interested in installing Deno. You can just go to that link and it'll have all of the instructions that you need. So the next thing I wanted to talk about was how Deno does dependency management. Um, it works much more like a browser than Node.js does. So if you're familiar with doing dependency management on the front end, it's a lot more similar to that. Um, it is ESM only, so there's no common JS, no require function. There is actually a way to get those things. Again, I'll talk about that in a few slides. But just Deno out of the box is focused on ESM. There's also no npm or a package manager or a registry like that. Deno has something called Deno Land /X, which is kind of the package hosting for third-party modules. Instead of using a package.json file, Deno applications can use import maps, which are standard, not just something that was made up for Node.js. And the import maps will allow you to map downloads to whatever you want to call the package whenever you're using it in your code. So if you had a module here called FS, which is kind of shown in the example at the bottom of the slide, you can actually take your import map, stick that URL in there, and then you could actually call it something else if you wanted. You could call it myFS or anything like that. There are also CDNs. So a famous one is esm.sh, where it will actually pull CommonJS modules from the npm registry, transpile them to ES modules, and then you can download them from there. So that if you're not able or not wanting to use CommonJS, that gives you access to CommonJS code, but still in an ESM format. And so there's a global cache module, or I'm sorry, module cache that is on your system instead of having your local node modules directory in every project. And so whenever you run your Deno application, like the one shown here, Deno will automatically download any dependencies that you have, put them into your module cache, and compile and run your code. And another nice kind of tool that Deno provides is something called Deno Vendor, which for production apps allows you to pull in all of your dependencies and save them in a way that you can check them into something like source control. Because whenever you're deploying your application to production, you don't want to be installing as you're trying to deploy. So if you can vendor all of your modules ahead of time, you just have to start your application up. And so I have this little example at the bottom here. I have the same example on the next slide, so let me jump over to that. So we have something called our standard library. So think about if you were using Node.js, the core modules like FS, HTTP, and things like that. These are modules that are maintained by the core team. So they're guaranteed to always be maintained and working with Deno. Every time we do a new release of the Deno runtime, we also do a release of the standard library. So we keep these things in sync. Everything is tested together, so it's kind of um, stamped as approved by the Deno team for use. And you can browse the latest version of the standard library at deno.land/std. But you can import code directly from there because Deno uses HTTPS imports. So the example here shows importing the FS module standard at 0.159.0 and destructuring out a copy function, which will copy one file to another. And then the example here shows copying the file source.txt into the destination.txt file. So you could leave off the at 0.159.0 and Deno would automatically pull in the latest version, but it would warn you about that because we do recommend pinning to specific versions. And I talked a little bit a minute ago about deno.land/x. So this is the closest thing that Deno has to an npm registry. So anybody can really go there and publish their own modules. The import scheme works similar to the standard library, so you can have different versions here and pull in whatever version you want. We're also currently redoing the website that powers /x. It's gotten a huge overhaul in the past weeks and months. So it now shows things like whether the module is popular or not. It can rank modules by popularity. You can browse all of the different versions, look at documentation, and all of the things that you would kind of expect from whenever you visit an npm packages page. So the next thing I wanted to talk about is the Deno release schedule. We have weekly patch releases. So actually, I just cut version 1.26.1 yesterday. And then we have monthly Semver minor releases. So this is when we ship new features in our stable releases. So these things normally happen on Thursdays. Yesterday was Thursday, so we had a patch release. Occasionally, there are Semver major releases. We don't have a set schedule for that yet. We're only at version 1, so there's only been one Semver major so far. And Deno does not have a long-term support schedule yet. So if you're accustomed to using Node's LTS schedule, Deno has not put one of those together yet. Okay, so now that we understand how to import code and how the dependencies work, I wanted to show a quick Hello World application here. So the very first line, we're importing a function called serve from the HTTP module in the Deno standard library. Serve is a function for starting a simple server. It'll automatically listen on port 8000 for you by default, but you can configure that if you need to. And it also will print out a little message for you letting your users know that the server is listening on port 8000. So we call on line 2 here, we call the serve function. It takes a handler function, in this case an arrow function, that just returns a response that says hello world. This response object is a global, the same as it would be in a browser. So if you're familiar with using request and response with the fetch API, it's the same thing. And then to execute this application, you would run Deno run. So run is it's not like Node.js where you just execute a file. You actually tell it you want to run a file. And then we pass in this -- allow net. This is part of Deno's permission system that I'll talk about in a minute. But basically, it lets you configure what your application has access to do. And then our server.ts file, which is where we would put the code that's on this slide. So a few notable features about Deno that I think kind of differentiate it from Node.js is a strong focus on web platform compatibility. The web APIs are what drive Deno. It really tries hard to not invent their own custom APIs. Again, Node.js has a lot of this, but it's because Node kind of predated all of these web APIs. Now that the platform has it, let's use them. Deno has a really powerful integrated tool chain that I'll talk about. We do support TypeScript out of the box, so it's not just a JavaScript runtime. The permission system that I talked about in the previous example, I'll dive into that in more detail. And then Node.js compatibility. So, Node has this huge ecosystem. Deno is kind of the new kid on the block. By having Node.js compatibility, it builds a bridge for Node developers to bring their code to Deno. And we'll talk about that in a little bit as well. So regarding the web platform compatibility, as I mentioned, Deno prefers to use web platform APIs whenever possible. I have a table here of just some of the different web APIs that are supported by Deno. So the cache API, for example, just landed in our most recent Semver minor release. We have timers, performance, web crypto, recently added support for the unhandled rejection event, web GPU. So, all these things that you see here, plus more. I'm not going to list them all one by one. And then Deno is also part of the browser compatibility tables, as shown on the picture on the right here. So this is actually the browser compatibility table for set timeout. And you can kind of see in the far two right-hand columns, it says, Deno has supported set timeout since version 1. Node.js has supported it since 0.10, but it doesn't have a nice check mark there because Node.js is actually not spec compliant. So it returns a timeout object instead of a timeout ID. So this is just one example of, Node kind of doing its own thing and Deno coming along and trying to stick to the standards more. So next I want to talk about the integrated tool chain. So Deno gives you a lot of tools out of the box that Node just does not. So first thing that everyone needs are a linter and a formatter. So if you were using Node, you would probably set up something like ESLint and Prettier, whereas Deno out of the box, you just write Deno lint and Deno format, Deno FMT for format. Deno also has version manager built in. So instead of using something like MVM, which you would use for Node, which doesn't even work on Windows as far as I recall, Deno has a command called Deno upgrade. You can automatically upgrade to the latest version or, specify a version number and jump between versions. Documentation generation. So you might use something like typedoc in Node, whereas Deno has the Deno doc command. Task runner, so something like grunt or gulp or even npm scripts. Deno has something built in called Deno task. Deno also has a bundler built in. You can run it with Deno bundle. This is similar to something like Webpack on the Node.js side. For test runner, both runtimes actually have this built in. So Deno test is what you would use on the Deno side. Node just recently in the latest major version added support for an integrated test runner. So even this is fairly new on the Node side. Packager, so if you use something like PKG in Node to create a single executable from your application, you can do the same thing with Deno compile right out of the box. And then for running TypeScript, I mentioned the Deno run command before. That's similar to something like TS Node on the Node side. And then you can see all of the different available subcommands. Just run Deno -- help. So next I wanted to talk about the out-of-the-box TypeScript support. So Deno does support TypeScript and JavaScript both out of the box. The TypeScript 4.8 compiler is snapshotted into the Deno executable. It uses SWC for transpilation and bundling. SWC stands for Speedy Web Compiler. It's a JS/TypeScript tool. It's written in Rust, and it's about, I think, 20 times faster on a single thread than Babel is on the Node.js side. And I think if you use multi-core, it can jump up to like 70x or something like that. So it's really fast. We do cache all of the transpilation, so you don't have to, keep transpiling every time you run your code if nothing has changed. You can configure the TypeScript compiler from the CLI by passing in a config file. It's generally not needed, and we also don't recommend it. We have a TypeScript configuration that should satisfy most people just out of the box. Next, I wanted to talk about the permission system. So Deno, if you've ever used WebAssembly, it's kind of similar in the fact that it can't do a lot out of the box. We don't let you talk to the operating system. We don't let you talk to the network, the file system, anything like that. You do have to explicitly grant permission to your process for anything that you want to allow it to do. So we have a whole list of CLI flags that I've included here on the right for accessing different things. So if you wanted to use environment variables, you would pass the dash dash allow env flag. If you needed to do something with high resolution time, we have the allow HR time flag. For accessing the network, if you wanted to, visit, pull in things from a website or an API, we have the dash dash allow net. Deno has a foreign function interface for interacting with code written in other languages. To be able to access that, you would use the allow FFI flag. The allow read and allow write flags are used for accessing the file system, so reading and writing respectively. Allow run is a flag that you would use if you wanted to spawn a child process. Just in the most recent minor version, we added this allow sys, which allows you to do things like access different things from the operating system that you previously needed to use the allow env flag for. So those are now more granular. You can control them better, and you don't have to give more permissions than your application actually needs. And then if you just if you're testing or if you're used to the Node.js model where anything goes or you just don't care, we have the dash dash allow all, which is also available as dash capital A. And that will basically bypass all of the permissions. You can do whatever you want. So I do have a little note here that subprocesses and dynamic libraries are not restricted. So if I'm running my Deno application and I create a Deno subprocess, those same restrictions are not passed down to the subprocess. You would have to specifically pass in flags to configure that, or if you're running something that's not a Deno process, there are no guarantees about what it can do. It has full access to the system as if you ran it from the command line. Permissions do apply to the whole process, so I can't import just the FS module and give that access to the file system. Any permissions that are granted are available to all of the code running. And you can actually configure some of the permissions to be even more granular. So if I only wanted to allow my application to read a very specific environment variable, but no other environment variables, I could pass that in with the allow env flag. Similar if I wanted to allow specific network connections or access to read and write specific flags, all of that can be configured at a very fine-grained level here. Real quick, I wanted to talk about the Node.js compatibility layer. So, I'm not going to make a claim that we have 100% compatibility with all Node.js code, but we do have a lot of the core modules implemented in our standard library. On the right here, I have the Node LTS release schedule. So the red line going down, it kind of shows where we are. It's October 2022. Node 16 is about to transition from active LTS into maintenance. At the same time, Node 18 is going to transition into active LTS. So we have recently updated our tracking to be on Node 18.8.0. It was previously Node 16. And then we will update our standard library again later this month once Node actually enters LTS. So Node will say, this is the first LTS version. We'll upgrade our standard library, and then you'll have, Node LTS support in Deno. I put a little asterisk next to the stream module here. We had our own hand-rolled streams implementation. We recently ripped that out. We are now using the readable stream module. So if you're familiar with that, it's an NPM module that kind of hides all of the breaking changes between Node.js versions for streams. Instead of trying to keep up with the code base there, we thought it made sense to just vendor that in as well. And we are currently working on supporting some specific high-profile modules like Vite, Prisma, and other things like that. We also recently added support for NPM compatibility. So You can see here you can start an Express server if you import Express from npm:/express, and then you optionally can specify a version number here. This was done because npm is a huge ecosystem, and leaving all this code out just didn't seem fair to Deno developers. Um, I should probably say, as a Node person, historically, it's probably time to stop using Express and look at something else. But a lot of people love Express, so it makes for a good demo here. Some of the bigger, most recent changes that would have gone into Deno this year. Web crypto. Just yesterday, we released a version that has the Node API if you wanted to use compiled add-ons similar to what you would use in Node. Deno Bench for doing benchmarking. Deno Task is our task runner. Deno Spawn is a new API for doing child process work. The npm support that I just talked about. The new Flash server, which is behind the Deno.serve API. So far we're seeing huge performance gains there compared to our previous HTTP server. And just a whole lot of other performance improvements. For the FFI has gotten a lot faster, startup has gotten a lot faster, just things like that. And you can try all this out, just install Deno, or if you already have it, just run Deno upgrade and you'll get all of this. Real quickly, I wanted to talk about Deno Deploy. It is a global distributed JavaScript VM. We call it a V8 isolate cloud. It allows you to run all of your Deno applications at the edge around the world very quickly. We're at over 30 regions globally and growing. Everything's built on the same open source crates as the open source project is. It's powering things like Netlify edge functions and Supabase functions. And then I actually recently did a little blog post about how this all works internally. If you wanted to take a look, I have the link here. We also have a bunch of showcase applications for Deno Deploy, so you can see a real blog, a real chat application, a Calendly clone, and we have a merch shop. So it's an actual website where you can go and buy merch. It's powered by Shopify on the back end with Deno on the front end. And then there are user provided showcases as well, so people can come and build applications and show people how to build their applications with Deno Deploy. Finally, I wanted to just share some important links: the Deno documentation, the standard library, third-party module registry, the source code for the standard library, the source code for the CLI itself. We do have a Discord server, so if you wanted to join that, there's the link. And if you wanted to try Deno Deploy, there's the link as well. I will say, you don't have to enter a credit card. There's a pretty generous free tier. It's fast. It's fun to use. So yeah, I would suggest getting out there and giving it a shot. And that is everything from me. Thanks again for allowing me to dial in, and now I can cross off giving a talk at 4 a.m. from my bucket list.
Wow! Thank you so much!